Alright, today we're going to talk about special products of binomials. So, we learned about the FOIL method last class. Now, as a review, and I'm going to just generalize how that FOIL method works. If we were to take, say, a plus b and square it, we can rewrite that as a plus b times a plus b. And to FOIL this, we would have to go a times a, the firsts. A times a is a squared. A times b, the outside terms, so we'd get an ab. Our inside term is b times a, which is going to give us another ab. And then our last terms, which is going to give us a b squared. Well, we can combine those to make a squared plus 2ab's plus b squared, which this is a generalized formula for what we call perfect square trinomials. So this right here is called a perfect square trinomial. And we call it that because it is what we get when we square a binomial, when we multiply a binomial by itself. So let's look at a couple examples. So we'll call this example 1a. We'll do, within example 1, I think at least 2 problems. So we're going to take x plus 4 and we're going to square it. And rather than foiling it, we can use that formula we just came up with, where we say x is in place of the a, and 4 is in place of the b. So we, on the last page, said a plus b squared is a squared plus 2 times a times b plus b squared. So instead of foiling, which that is a perfectly fine way to solve this problem, we're going to just take the x, which is in place of a, we're going to square it, plus we're going to go 2 times a, which is x, times 4, which is now in place of b, plus 4 squared. And then we simplify it. 2 times 4 is 8. So we're going to have x squared plus 8x. 4 squared is 4 times 4, so that's 16. So our answer is x squared plus 8x plus 16. Let's do one more. For sure one more. We're going to take 1b. We're going to have 3x plus 2. Y, and then we're going to square that. So again, we're going to use that same formula, but in this case, a is the 3x, b is the 2y. So if we use that formula, we're going to take 3x and square it, plus 2 times 3x times 2y, plus 2y, and we're going to square that. Well, 3x squared is 3x times 3x, which is going to give us 9x squared, plus 2 times 3x times 2y. Well, 2 times 3 is 6. 6 times 2 is 12. xy, plus 2y squared. 2 squared is 4. Y squared. So our answer is 9x squared plus 12xy plus 4y squared. And I feel like I should do at least one more, if not two. So let's do that. we're going to continue on example 1. And there's reasons behind these next two that I want to do. So 1c, we're going to take 4 plus s squared, and we're going to square that. So in this case, our a is 4, and our b is s squared. So we're going to take our a squared, 4 squared, plus 2 times 4 times s squared, plus s squared squared. Well, 4 squared is 16, so we're going to end up with a 16. 2 times 4 is 8 s squared. And when we take the power of a power, remember we multiply those powers. So we're going to end up with s to the 2 times 2, which is 4. So our answer is going to be 16 plus 8s squared plus s to the 4th. Then I am going to do one more, 1d, not to be confused with One Direction. We're going to take negative m plus 3 and square it. So in this case, a is negative m, b is 3. So we're going to write this as negative m squared plus 2 times negative m times 3 plus 3 squared. Well, if I took negative m times negative m, a negative times a negative makes a positive. So we're going to end up with positive m squared. 2 times negative m times 3, well, 2 times 3 is 6, and a positive 6 times a negative m is going to make a minus 6m. And then 3 times 3 is 9. So we're going to get m squared minus 6m plus 9. So there's another type of special binomial product we need to look at. So we just looked at if we have the sum of two terms squared, what do we do? But what if we have a minus b and we square it? Well, we know we can write that as a minus b times a minus b. And if we FOIL it, we're going to get an a squared. We're going to get a minus ab and another minus ab, and then a plus b squared. And we can combine those middle terms to get a squared minus 2ab plus b squared. So the only difference between the perfect square trinomial that we looked at before and this one was the plus sign and the minus sign. So if we have a plus sign in the middle, so if we have a, you don't have to rewrite this part, a plus b squared, we're going to get a squared plus 2ab plus b squared. If we have a minus b squared gives us a squared minus 2ab plus b squared. We're always going to have a positive on the front and the back, but that middle term, the sign of it, is going to depend on the sign of the binomial. So if it's a plus sign in the binomial, we're going to have a plus sign in the middle term. If it's a minus sign, we're going to have a minus sign. So let's look at an example. This will be example 2. And we'll only do a couple of them because I kind of got the point of negatives and squaring a term with a power taken care of in the last one. So example 2a, we're going to look at x minus 5 and we're going to square it. So again, this is in the form a minus b squared. And we can write that as a squared minus 2ab plus b squared. So we're going to do that here. This time a is x, so we're going to have x squared minus 2 times x times negative 5 plus negative 5 squared. In fact, real quick, I should not have put a minus with that negative 5. That should be just a 5. And this 5 should also be just a 5, not negative. X squared is going to just give us an x squared. 2 times x times 5 is going to give us a minus 10x. And 5 squared is going to give us 25. So our answer is x squared minus 10x plus 25. So in this case, our A was x, our B was 5, not negative 5. That was my mistake. Let's look at one more in example 2, and then we can probably move on. Let's look at 4c minus 3d, and we're going to square that. So in this case, our A is 4c, our B is 3d. So we can write that as 4c squared minus 2 times 4c times 3d plus 3d squared. Well, 4c squared is going to be 16c squared minus 2 times 4 times 3 is 8 times 3, which is 24 CD plus 3D squared is going to be 9D squared. So our answer is 16C squared minus 24CD plus 9D squared. And I only have one other special type of products of binomials to go over with you. So we've looked at what would we do if we took a plus b and squared itself, a minus b and squared itself, but what if we have a plus b times a minus b? This is another special product of a binomial. If we FOIL this, we're going to get in a times a is a squared, a times minus b is minus ab, b times a is going to give us a plus ab, and b times negative b gives us minus b squared. Well, if I have two terms that have the same number, the only difference is one's positive and one's negative, they cancel each other out. So these middle terms cancel each other out. They're gone. So we're going to only be left with a squared minus b squared. This has another special name. So the last two we looked at were perfect square trinomials. This one is called a difference of two squares. Difference because we're subtracting, two squares because we are squaring two terms. So let's look at our final example. Example 3. We'll do 2 from here. Our first one is going to be take x plus 6 and multiply it by x minus 6. So we're going to utilize the formula we just looked at. We've got a plus b times a minus b, and it's going to equal a squared minus b squared. In this case, a is x, b is 6. So we can write this as x squared minus 6 squared. Well, x squared is just going to be x squared. 6 squared is going to be 36. So our answer is x squared minus 36. Let's do one more. One that has multiple variables. So we're going to look at x squared plus 2y times x squared minus 2y. In this case, our a is x squared, our b 2y. So we're going to square x squared, and then we're going to subtract and square 2y. Well, x squared squared. Powers of powers say we multiply the powers. So we're going to get x to the 4th minus 2 squared is 4 and a y squared. So x to the fourth minus 4y squared is what we're going to end up with for example 3b. And that's going to wrap up our lesson on special products of binomials. In the next video, we're going to talk about dividing polynomials.